Good morning students, welcome to challenge series. In this video, we are going to solve a problem from the unit current electricity. In this, I have considered this question from the JEE Advanced 2012 paper. In this question, we get a circuit like this. About this circuit, there are 4 statements. We have to find which of these are true. Let us see first this circuit. It consists of some configuration of resistors like this. The first statement is about current through PQ is 0. What about the current in this branch? Second statement, I1 is equal to 3 amps. That means what is the current in the circuit flowing? Next, I2 is 2 amperes. 2 ampere should be flowing through this branch. I2 is the current through 2 ohms branch. Next, last statement is the potential at S is less than that at Q. That means what is the potential relation between this point and this point? So this should be lesser than this. These are the statements given about this question. Let us see one by one. Before that, first let us find the equivalent circuit for this resistors configuration. I am taking this point as B, this point as B. If we find the equivalent resistance between A and B, we can get first current through this branch. And then remaining statements we can verify from that. First I am calculating the equivalent resistance between this point A and B. Let us see that. To find the equivalent circuit, I am writing these two resistors as, first I am plotting the circuit once again. These 2 ohms I am writing as 1 ohm in series with 1 ohm. This 4 ohms I am writing as 2 ohms in series with 2 ohms. And this 1 ohm as it is. And 2 ohm, 4 ohm resistors are connected like this. This is the point B and this is the point A. So let us write the values of these resistors. 2, 4, 4 this side and 1, 1 this side, 2, 2 this side and 1, 2, 4. These are the resistor values in ohms. What I am doing means this point, if you observe, these two are equipotential points. We can combine the equipotential points in the circuit so that the given circuit can be rewritten like this. This is 1 ohm, this is 2 ohm. And this 1 ohm, 2 ohm will be connected like this. Remaining circuit as it is. This is B, this is A. So the remaining resistor values 2, 4, 4 and here 1, 2, 4. If we observe this circuit, this is a Wheatstone bridge and this is also a Wheatstone bridge. 2 Wheatstone bridges we can observe here. Wheatstone bridge concept we know. Whenever the resistance relation is like this, R1 by R2 is equal to R3 by R4, this is a balanced condition under which the current flowing in this branch is 0. Here 2 by 1, if it is equal to 4 by 2, R1 by R2, R3 by R4 ratios we have to compare from this condition. R1 by R2, R3 by R4. This divided by this and this divided by this. If these two ratios are same, then the bridge is under balanced condition. Under the balanced condition of the bridge, there will be no current flowing through this branch. That is a Wheatstone bridge concept we know. So that these two are equal. So that the bridge 1 is balanced condition. This is balanced. So no current flows through this branch. We can eliminate this resistor now. Similarly, we can verify this Wheatstone bridge. Here 1 by 2 and 2 by 4. These two ratios we have to verify from this condition so that both are equal. So this bridge also under balanced condition. Under balanced condition there will be no current flowing through this 1 ohm resistor, so that we can eliminate this resistor from this. Then the resultant circuit I am writing here. This is 2142. Next bridge, that is 12 and 24. Further we can simplify this one. This is 3 ohm in parallel with 6. This is also 3 ohms in parallel with 6. That means 3 ohms in parallel 6 is equivalent resistance 3 into 6 divided by 3 plus 6. That means 18 divided by 9, 2 ohms. So here resultant 2 ohms, here also resultant 2 ohms. 2 ohms in series with 2 ohms, 4 ohms. So A to B, we can observe there is 4 ohms equivalent resistance in this circuit. Now let us complete the circuit. There is a 12 volts supply for this circuit. Then what is the current here? I1. We can find here I1. I1 is equal to 12 volts divided by equivalent resistance 4, that is 3 amperes. So up to this we can verify some options here. The current through the PQ is 0. This branch 4 ohm resistor current is 0, he has given. The first statement A, option A. That means this 4 ohm resistor, no current flowing under the balanced condition of this bridge. So that option A we can confirm that correct. Next statement is current I1 is equal to 3 amps. Where is the current means this one. This I1 current or this one 3 amps we are getting. That means option B also correct. So from this 3 amps, if this is 3 amperes, that means here 3 amperes coming. Then what about the current I2? I2 means current flowing in this branch. That means here the current flowing in this branch I2. What is the value of this I2? We need to find. For that, first let us find that current. Here the circuit, if you observe, 3 amps coming and this branch having 3 ohms resistance and this branch having 4 series with 2 is 6 ohms resistance. We need this current I2 if this is I1. So current division rule we can apply. According to current division rule, I2 formula is this current total current, that is I1 here, opposite resistance divided by total resistance 3 plus 6, and we got that I1 is equal to 3 amperes. So 3 amperes multiplied by 6 divided by 9, that means 3 times 3 2 times. So we got I2 is equal to 2 amperes here. So I2 value is 2 amperes we are getting. So option C is I2 is 2 amperes means this is also correct statement. And finally, if you observe, the potential at S is less than that at Q. Here Q point is here. This resistor is near to this positive terminal of the battery. So obviously Q is at a higher potential than T or S. This is far when compared to Q. So Q should be obviously at a higher potential when compared to S. So that option D also correct. So in this question, options A, B, C, D all are true. Right. Thank you.